Hi and welcome to the video on the area of sectors. By the end of this video you should know what a sector is and how to find its area. So let's take a look. Sectors are just fractions of a circle. Common sectors are semicircles, which represent half a circle, and quadrants, which represent a quarter of a circle. Let's see why a semicircle is half a circle. Besides two of them making a whole circle, the formula for the area of this circle, semicircle, would be a half times pi r squared because it's half a circle. But the fraction really does come from the angle that is at the center of this semicircle. The angle at the center of the semicircle is going to be a straight line, which is 180 degrees. Now that 180 degrees represents 180 out of a possible 360 because we know that a circle adds up to 360 degrees. If we were to simplify that fraction, 180 out of 360, we would get a half. So that's where the half comes from. Let's take a look at a quadrant, and we know that the area of a quadrant is going to be a quarter times pi r squared because a quadrant is a quarter of a circle. But let's see where that quarter comes from. The angle at the center is a right angle, and right angles are 90 degrees. That 90 degrees represents 90 out of a possible 360. If we were to simplify that 90 out of 360, we would get the fraction 1/4. So the fraction of the circle that the sector represents actually comes from the angle at the center of the circle. So let's take a look at a sector with an angle of 50 degrees. This is not one that you can just look at and say, oh, I know what the fraction of the circle is. I know that's easy. We know that the fraction of the circle comes from that 50. That represents an angle of 50 out of 360 degrees. That's our fraction. If we then times it by the area of a circle, pi r squared, we get the formula for that particular sector. What we want to do though is have something a little bit more general, something that we can use for any sector. So let's take a sector of a circle with an angle that we're going to call theta. Theta is a Greek letter of the alphabet, and we use Greek letters to represent angles that we don't know the value of. Now that theta could represent any angle from 1 degree all the way up to 360 degrees. If we were to work out the fraction of that circle, I would take theta and put it over the top of 360. That's what the fraction of the circle is. If I then want to find the area, I would just take that fraction and times it by pi r squared. So this is the formula that we're going to use for the area of a sector. So I'm going to give you a couple of examples now, and I'm going to use this formula to work out those areas. So let's look at number 1. Number 1 has an angle at the center of 120 degrees. So our fraction is going to be 120 out of 360. Let's begin by writing out the formula that the area equals theta out of 360 times pi r squared. Theta is the angle, which is 120. So our area will be 120 out of 360 times pi times 2 squared, because 2 is the radius. So our area is going to be about 4.19 centimeters squared. Let's look at number 2. Can you work out what the fraction of the circle is? If you said 70 out of 360, unfortunately, you're not correct. We want the angle that is at the center of the circle inside the circle. Now that whole center of the circle adds up to 360 degrees. So if we want to work out what that red angle is going to be, we're going to have to do 360 minus the 70. And that will give us an inside angle of 290 degrees. Now we can go ahead and use our formula. The area of this sector is going to be 290 out of 360, that's the fraction, times pi times 5 squared. And that gives us an area of 63.27 meters squared. What I'd like you to do, please, is pause and summarize this screen. This is the only one. And then use the 2 worked examples in order to get some answers from your text tomorrow. And that's it. Hopefully you know what a sector is and how to find the area of a sector. And as always, ask questions and I'll help you out. Good luck.